let us finally, for now, look at still moles in solution, but we are going to go to how to finding number of moles of substances in given volumes of their standard solutions. So in our calculation, we are going to look at how to get the number of moles of substances when we have been given their solutions with known concentration. In this case, the concentration we are talking of in this case is molarity. For example, supposing I have 25 cubic centimeters of a 0.1 molar sodium hydroxide solution. This is a standard solution with a known molarity, it is 0.1 capital N. And out of that solution, we have only 25 cubic centimeters. So how many moles are in the 25 cubic centimeters? We are looking for the number of moles of sodium hydroxide in the 0.1 molar sodium hydroxide solution. So this is a standard solution. The molarity is given, but we have a small volume removed. So how many moles of sodium hydroxide are here? So we are going to go and understand firstly the meaning of what we call molarity. So to remind us always, remember that molarity is the number of moles in 1,000 cubic centimeters of the solution. So if we can be able to remember this always, it will make us be able to get the number of moles in a small volume or in some volume of that solution which has been stated. So let us try to see how to get the number of moles of sodium hydroxide in the 25 cubic centimeters of 0.1 capital M sodium hydroxide solution. So we are starting from here. This is our starting point. We shall say 1,000 cubic centimeters of the sodium hydroxide solution contains 0.1 mole. We have only written the expression of the molarity because molarity is the number of moles in 1,000 cubic centimeters. Remember, we are looking for number of moles here. So moles goes to the right hand side and volume will be on our left hand side. But we start with the molarity. We start by writing the expression of molarity. So 1,000 cubic centimeters of the sodium hydroxide solution contains this number of moles, 0.1 mole. And then what of the 25 cubic centimeters of the sodium hydroxide solution? It contains, we cross multiply 0.1 times 25 over 1,000 and the unit remains mole. So let us look for this. Our answer is 0.0025 mole. You can use your calculator and check this. So it is 0.1 times 25 and we divide by 1,000. Our answer is 0.0025 mole. And that is the number of moles of the sodium hydroxide in the 25 cubic centimeters of its solution. As simple as that. Let us look at another one here. I have, let's say 12.5 cubic centimeters of sulfuric acid with, and the sulfuric acid, let us get the molarity, if the molarity is say 0.25 capital M. So 12.5 cubic centimeters of 0.25 capital M sulfuric acid solution. Let us look for the number of moles in the 12.5 cubic centimeters of this solution whose molarity is here. So we start from the molarity in this case by interpreting with the molarity, which will help us to get the number of moles in this volume here. So we start by saying 1,000 cubic centimeters of the sulfuric acid solution contains 0.25 mole. Please do not repeat capital M again. We have already interpreted this one this way. So this one is the number of moles in 1,000 cubic centimeters. Fully interpreted. So I expect this unit to be mole, not capital M again. So if 1,000 cubic centimeters of the sulfuric acid contains 0.25 mole, then what of 12.5 cubic centimeters of the sulfuric acid solution that we have been given? What does it contain? So it contains, we cross multiply 0.25 times 12.5, we divide by 1,000 mole. And what do we get? So it is 0.25 times 12.5, and we divide by 1,000, we get 0.003125 mole. So in this case, in case you have been given the molarity of a solution and some volume of the solution, and they ask you for the number of moles of that substance in that solution, please start by writing a statement to interpret the molarity by starting with 1,000. We are not using liters in this case, we are not using cubic decimeters because our volume is in cubic centimeters. So we say 1,000 cubic centimeters of that very solution contains the number of moles, which is the value of molarity, and the unit must be mole because we are interpreting this molarity here. Like in this case, we have done it as 1,000 cubic centimeters of sulfuric acid contain 0.25 mole. Then what of the volume given, the 12.5 cubic centimeters of the sulfuric acid? It contains, you cross multiply and you get your answer. So mark you that there is nowhere you are going to write capital M anywhere. So capital M is the value of molarity, and that is if and only if you have calculated molarity. But here we are calculating number of moles. So let the unit remain mole. Let it flow until when you get that number of moles, it will also be in moles, not capital M, because capital M is molarity. Now, in your free time, please do for me this for the sake of your practice, so that you get conversant with this simple calculation here. I hope you'll take time and try these numbers here to exercise your chemistry muscles. So, this is a simple exercise. So, calculate the number of moles of each of the following substances in their given or in the given volumes of their standard solutions. So we have 10 cubic centimeters of 2 molar hydrochloric acid. Hydrochloric acid. I have 30 cubic centimeters of 1.5 molar potassium sulfate solution, and I have, say, 50 cubic centimeters of 0.01 molar ammonia solution. So try these three, and then of course you'll be exercising your muscles in the calculation of number of moles. This is Step Talks Education. Thank you for viewing.